In this course, we will be learning about the tool HYPERMESH and the solver RADIOSS. HYPERMESH is a universal preprocessor that is widely used in the industry. RADIOSS is the most preferred solver for structural analysis. This course features 48 hours of classroom sessions, 10 online videos, topic-wise assignments, module-wise assessments, session-wise MCQs which are held online, and 15 hours of project. In Module 1, you will be learning geometry processing. You will be introduced to HYPERMESH and RADIOSS. You will learn how to import a geometry, CAD, and the GUI. You will learn how to create and edit HM entities such as nodes, distance, planes, surfaces, solids. You will then move on to geometry cleanup, where you will learn topology cleanup of airplane wing rib, rotation, translation, reflect, position, and projecting elements, nodes to surface. In Module 2, we'll be going through 2D surface meshing. Under this, you will learn 2D meshing of sheet metal components such as introduction to BIW parts, types of finite elements, quality parameters and criteria file settings, 2D meshing using AutoMesh or B-Pillar. We'll then move on to 2D mesh quality evaluation, where we'll check connectivity of a mesh, element normal corrections, remeshing, checking and correcting element quality as per industry standards, and learning the best practices for crash and structural analysis. In Module 3, we'll be going through mid-surface processing. Here you will be introduced to mid-surface, where you will learn meshing for plastics, BIW, and sheet metal components, mid-surfacing, auto mid-surface generation, editing, meshing, thickness assignment to the mesh, and manual element offset method. In Module 4, you'll be learning 3D Tetra Meshing. Here you will be introduced to 3D elements, and under Tetra Meshing you will learn Tetra Meshing of 2D surface volume, volumetric Tetra Meshing, setting Tetra Meshing parameters, and refining a Tetra Mesh. In Module 5, you will learn 3D Hexa Meshing. Here you will learn Hexa Meshing using drag, line drag, element offset of a shackle, solid mapping, multi-solids, and linear solids. In Module 6, you will be learning 1D and assembly meshing. Here you will be introduced to 1D meshing and assembly, where you will learn introduction to hyperbeam, creating 1D elements such as rod, bars, and beams, orientation of 1D elements, and then you will later move on to connectors such as RBE2 and RBE3 elements, spot, bolt, seam connections, and importing and assembling components. In Module 7, we will be learning about linear static analysis. We will first be introduced to linear static analysis and then introduced to RADIOSS and bulk data entry. Under this, you will learn consistent units for FE analysis, preparation of input files using HM, control arm of a heavy truck, define loads and boundary conditions, creating a coordinate system, applying force, moments, pressure, and gravity, applying constraints, supports, creating load steps, requesting outputs, exporting solver decks. You will later move on to checking model using solver browser and model checker. You learn solver settings. You will also learn executing static analysis of an impeller type pump, post-processing, and checking the out file and the FEM file. In Module 8, you will learn normal modes or modal analysis. Under this, you will be introduced to normal mode analysis, solution process for normal modes analysis of a splash shield, defining EIGRL card, defining normal modes load step, running normal modes analysis, post-processing using hyperview, plotting mode shapes, and animating mode shapes. Module 9 consists of post-processing. Here you will learn interpretation of warning and errors, error fixing, results processing in local and global frames, results plot generation, extracting various stresses, element force processing, section force processing, and XY data processing.